Alright, so in this video we'll be creating a CICD pipeline with Jenkins and Docker to push a React application to Docker so that we can run it on our machine, or we can use it in a cloud provider if needed, or whatever use case that you want for that Docker image. So in this case, as you can see on the screen, I have Jenkins open up. It's running on localhost 8081 because I have a Jenkins version running on Docker. And if I click on this React app, you can see that there is a master branch, right? And this is running our pipeline, right? So we have one that's gonna get the information or our code from GitHub, right? So it's gonna check out the information, see the environment. So it's gonna print out necessary information about the environment, install the dependencies that is needed for the React application. It's gonna run the test for our React application. It's gonna build the image and then push that image to Docker Hub by deploying that image. So if I switch screens over here, you can see that I have a demo container running, which is holding our Jenkins application, right? You can see that the port is 8081 because if I go back, you see that it is running on localhost 8081. So we're going to be utilizing Docker to have a Jenkins version or a Jenkins container running locally. Now, what can we do with a image that is published to our account? Well, what we could do is use Docker run. So I already have a command for that, and let me see if I can make this a little bit bigger. All right, cool. So I have this Docker run command, which will first port our application to run on localhost 8000, right? And I have it running detached, meaning, hopefully you guys have some Docker experience before watching this, but detach just means that it's going to be running in the background. Then I have this remove flag, which says that when I stop the container, it's just going to remove the container. So for example, this Jenkins container that is running, right? Once I press stop, if it has this remove flag, it will just remove the container, right? It won't save it like it does here with this off service, right? This off service is not running, so it's waiting for it to be restarted again. But if I were to stop this Jenkins app with this remove or this RM flag, it will just delete the container. And then I gave the container a name, right? Because if we don't give it a name, then Docker is going to give it a randomized name, and sometimes those names can be kind of funny but not very descriptive. So giving it a name with the name flag is useful. And then I got the image name, which is in this case TechWithGeo/React app, and this is the image that was published to Docker Hub. So if I run it, it's going to give us a hash of pretty much identifier for our container, and we can see that it popped up here, right? We have this demo app that is running, and we can see that it's running on 8000, and it is running TechWithGeo/React app, the latest version of it. So going over to localhost 8000, we can see that there is a template React application running. Now, whatever React application that you want to use, you can use it, but I just used a bare bones React template as an example in this case. So that's pretty much all we're going to learn throughout this process. I wanted to give you guys a visualization on what we'll be doing. So before diving into actually creating the pipeline, what I want to do is go over what is CICD, what are the tools being used, and what are some of the terminology that is currently being used throughout the CICD process. Now, if you don't really care about any of that and you already know what CICD is, then you can skip over to the creation of the pipeline. But if you want to know more about CICD, then continue on with the video. I'll leave a timestamp for each chapter. So I'll leave a chapter for the creation process and a chapter for the discussion portion. So hope you guys enjoy it. Let's get started. Alright, so what is CICD? Well, CICD is short for continuous integration and continuous delivery. It's a process used to deliver applications to consumers through automation. The goal is to set up a series of steps that allow for easy integration of new features and to continually deliver on those features. So you got to think about it. The difference is, we know that with the CI/CD process, right, when we push code or whenever a specific action is done, we know that we want to create a series of steps, and when that trigger arises, we want to run those series of steps, compared to having an engineer that does tests, having an engineer that checks the quality of the code, having an engineer that deploys the code. Instead of having to separate these things to be done manually, we could just have a whole flow for that done through automation. Now, CICD falls under the DevOps category of tech, and I found this great image that kind of describes or go over like this the steps within DevOps, right? And it kind of gives a good visualization of what it consists of, right? What is DevOps and how the CI/CD fits within it. So DevOps is a methodology used in software development. It's a practice and tools used to automate the work of a software developer for improving and shortening the development process. As you can see, the image shows pieces of that methodology. You have a process for code, including source code and version control, which is GitHub, Bitbucket, GitLab, Git in general. Then you have monitoring, right? Because you have to know what is going on. So that deals with logging and the visualization of data and requests coming through the system. Then you have operation, which we kind of already saw a visualization of it, right? Because with Docker, it deals with containerization, and you even have virtualization. So in our case, we'll be using Docker later, so it falls under containerization, like I said. And then a very important one is release, right? The reason why we made this whole deal of CI/CD, right? It's getting through all of this to have the final product in production so that users can utilize it. But there's a series of things that go on throughout the process, right? There's tests, there's the building of it, there's the planning of it, there's the infrastructure, there's the monitoring of it, even beyond production, right? We had to see if the production version of the application is running as expected. We got to make sure that with containerization that it's running consistently on any OS. There's a lot of things that go on with that within the software development process. All of these parts are a part of DevOps, and it's what streamlines the software development process. Speaking of streamline, let's talk about the CI/CD pipeline. So here's a nice example by Catalan, which shows what exactly a CI/CD pipeline entails. So the CI/CD pipeline breaks down tasks into chunks, and each chunk is a task that is executed before moving on to the next chunk. Usually there's a trigger to start the pipeline. Usually that trigger is a push to a branch or a pull request in the code repository. The code repository meaning where your code is being held, such as GitHub, GitLab, Bitbucket. With that code trigger, it triggers a build to see if that code can be built without any issues, right? So if it's a React application, usually we have a npm build to see if it can actually build into a production ready application. So this is what will happen initially to see if that application is in the format needed to actually be sent to the next step. Now, during any portion of these tasks being ran, if it were to break, crash, or fail, the rest of the pipeline will end at that task. There will be no point of moving on if any of it breaks. Then the next step will be passing tests. If the tests pass, now we can deliver the application to the staging environments. Applications are usually divided into different environments before making its way to production. Production meaning the app is available for real world users to see. And that is called the staging environments, right? Staging environments are made to test code, build code, check for updates to ensure that the quality is the same under production-like environments, but not exactly production. So usually it goes through all of these chunks, right? We commit the change, it triggers the build, it notifies us if the build is proper. If it didn't, then we can just stop the whole pipeline process. But if it did, then we can move on to the next chunk, which is running the test. It notifies the outcome of the test. If it passes, then we can deliver the application to staging, and then eventually, after passing through all the staging environments, we can hopefully one day deploy it to production. Now, I talked about staging environments, right? And usually companies like to divide these environments into chunks, right, before reaching to production, because production is the main source, right? It's what the users will interact with. So we got to make sure that it is proper before getting to the user. So we split it up, or usually it's split up into 4 environments. Usually there is dev, which is short for development, where programmers can test out new features, and I like to think of it as like the sandlot, right? Just as the name implies, it's used for development. It's like a playground for new features. Then there's QA, which is short for quality assurance. This is the environment that testers and the quality assurance teams use to make sure that everything is working, and that there are tests to make sure that everything is working as expected. So usually you'll work with a QA engineer to make sure that the proper tests are being used to ensure that every nook and cranny of the application is being tested and running accordingly. Then there is the UAT environment. This is the environment that is as close to production as possible, meaning that whatever database is attached to it, whatever CPU usage is attached to that environment is as close to prod as possible. And this is the environment that stakeholders and the end users use to make sure that it is running as expected. It has all the requirements that is expected. And like I said, it's essentially as close to the final product as possible. This is where you get the final feedback, right? Whether it's okay to go to production or whether it is not okay to go to production, and maybe you have to add a couple more features and then get back to that specific stage and get feedback again. And then you have production or prod, right? This is game time. This is what the users see, and if there are any issues in productions, well, it's an issue for everybody. This is the main source. This is where the outside world interacts with your application. This is, like I said, game time. So I've been rambling, but why is this all needed? Well, companies like to save money if you don't know, right? So time is money. You have a stage for compiling, linting, testing, and eventually deployment all through automation. We do not need an engineer for each task, right? You just need to set up the rules for one time and we're good to go. There may be adjustments here and there, but it shouldn't be that often, right? Now the programmers can just focus on code and getting features delivered. So like I said, time is money. And now we don't need an engineer specifically for each individual thing. We can just program, and you can have one engineer that needs to make adjustments to the pipeline. They can do that. It's usually the DevOps engineer, but now you don't need multiple engineers for that one task. And then there's consistency, right? The task will need to follow a series of rules for each stage. If a stage doesn't pass, then it will fail and the process does not continue. You do not want to deploy broken code, and this reduces the human error factor. Then we have methodology. With the CICD methodology, it allows for the delivery of new features with relative ease. A lot of companies use Agile, and with CICD, it makes delivering features at the end of sprints way easier. Just make a PR, and it triggers a pipeline to run, right? And if you were to merge that code into a branch like the main branch, then a deployment process can occur. Now, I know one thing that is done at my company and the other company that I work for was that there's a branch for each individual environment. So you would have a branch for dev, you would have a branch for UAT, QA, and then production. And each branch has a trigger, right? So if I were to merge into dev, well, that will trigger a deployment to the dev environment. If I were to merge into UAT, then there will be a trigger for it to push that code or push that application into the UAT environment. And then lastly, there's that production branch, right? That's the main branch. And if there were a merge into that branch, then it will trigger a deployment with a couple of rules, right? It would need a approval from the main leaders of that repository. But then after it got the proper approvals, then it'll be pushed into production. So that can all be done using a pipeline. Now we have a couple of tools to make this all work together. And the first thing that we'll need is the code repository, right? This is where the code is being stored and versioned using Git. We have different code repositories such as Bitbucket, GitLab, and the famous GitHub. And this is just used to store code and version the code using branching strategies like I just discussed, right? There may be a branch for each individual staging environment. So that's one strategy that can be used. So a developer will initially make a PR to dev, and then when stable in dev, can make a PR to QA. And once that's stable and properly tested in QA, then they'll make another PR to UAT, right? And then once that's stable, then you'll make the final PR to production, and that's where the real users can utilize the new feature once it's deployed to production. So there's processes in between dev and production, but usually there's a branching strategy in the code repository that reflects what you're trying to do in the pipeline. So there's tools for this, right? There's Jenkins and Travis CI, for example. There's many more, but these are some popular ones, right? Jenkins especially. So Jenkins help automate building, testing, and deploying, and facilitating continuous integration and continuous delivery. all we have to do is have some initial setup by providing a link to our code repository, which hosts our code, and a Jenkins file to set up the instructions on what to automate, right? Like the step of grabbing the code and installing the proper dependencies and then building it and then testing it. This can all be done within a file or a Jenkins file for Jenkins, right? These are just the instructions to automate the whole process. And Jenkins has been around for such a long time, and it's an open source, so it's still around because of the popularity, right? It's war ready. It's been utilized by a lot of companies. It's just trusted. And there are alternatives like Travis CI. It also does the automation process, but it is cloud-based, right? It is configured by using a YAML file compared to what Jenkins uses, which is the Jenkins file. It's also open source, but offers a more extensive version for a cost. Usually that's called the Enterprise Edition. Travis CI is restricted to being cloud-based only, but with the push for cloud the last decade or so, it shouldn't really be an issue. For this video, we'll be utilizing Jenkins because it's easy to set up and to have a functional pipeline. And it has a lot of community support just in case you need any assistance beyond what this video entails. And then we have another tool like Docker, right? Docker allows us to containerize our applications. So a container is a standardized unit of software, right? It's a package of code and dependencies used to run that code. So say for instance, we had like a Java application, right? Spring Boot or something, right? So that container will contain Java code with Java runtime because you need Java runtime to run Java code. A container is created using a set of instructions called an image. And how I like to think of an image is like a class. If you have experience with OOP, you know that a class is like a template or a blueprint to create something, right? And the instance of a class holds information regarding an object, right? Just like how a container is running software based on an image, right? It's like a blueprint. And the plus of using Docker is that creating a container always yields the same exact application and behavior, no matter where you spin that container up or wherever you use that container. It has the same expected behavior and same exact version of the application. So this is why we'll be using Docker in our example as well. And then we have the cloud. Nowadays, instead of companies having in-house servers, a lot of companies have migrated to the cloud. So companies have worked together with companies like Amazon, who has AWS, Microsoft, who has Azure, and Google, who has Google Cloud Platforms, to pick up the load of putting their applications on their servers instead of creating in-house servers. They do not have to worry about building servers and infrastructure anymore. All they have to worry about is paying for what they utilize for the services that are hosted on Amazon servers or Microsoft servers or Google servers. And they still have control over things like security, so they don't have to worry about that. And if anything, Microsoft, Amazon, and Google make sure to have their servers in very safe locations and to have different locations for their servers. It may be more robust than what a company can have themselves. So companies have no problem offloading that responsibility to Amazon's and Azure and Google. And we can create our pipeline in the cloud as well on a virtual machine on a cloud server. It will still listen for triggers such as a pull request and merges, but now it's being stored on a server that AWS, Azure, and GCP has. And AWS, Azure, and GCP even have services that will allow for the creation of a pipeline to be much easier. And we can even host our application on the cloud, right? So even beyond the pipeline, we can have our React application running on a custom domain and running on an AWS or Azure or a GCP service. So what we'll be doing in this video is that we'll be creating a pipeline that will create a Docker image and push it to Docker Hub. But in the future, we can take that Docker image that we created and run a container on a cloud service like AWS ECS, for example. But that's for another video. So hopefully you guys got a good understanding of the tools that DevOps have to offer. And there's a lot more to it, but these are the basics that you'll need to get a running pipeline going. So let's actually see that in action. Let's actually create a pipeline. Alright, so let's get started. So before we officially get started, what you'll need is a couple of requirements downloaded. So you'll need Docker because we're going to be running a Docker container for Jenkins. And you're going to also need Node because we will be using a React application. So to actually create the React application, you're going to need Node. And you're going to need an editor. In my case, I'm using Visual Studio Code, but you can use whatever editor you're comfortable with. I just like Visual Studio Code. So yeah, that's pretty much what you're going to need. So let's go in. I already have it open up in a folder structure. So I have a folder called Jenkins Pipeline. So go ahead and create a parent folder and open that up. And then within that folder, I'm going to first open up a new terminal, and I'm going to create the React application to go inside of that parent folder. So let's do npx create -react -app. I'm going to just call this simple React. Press enter, and that should start creating the template for a basic React application. Alright, so cool. As you can see, it's done. We have a fresh simple React folder, and it has everything that it needs to run a React application. And you can see that there's a message here that says, to begin, right? You just go in cd into simple React and do npm start. So let's do exactly that. Let's do cd simple React. Let's do npm start, and it should start to run the development server for our React application. Alright, boom. So it should be running on localhost 3000. So let's check it out. So nice. This is what I see on localhost 3000. Now, if you guys want to change this and make this more fancy, you could. But in this case, I'm just going to leave it as the basic template that is provided straight out of the box, right? But you can adjust the React application based on whatever you want. All you got to do is go into the folder that was just created and just change around the file structure, right? Right here it says you can go in and edit the app.js file and edit it and adjust it and reload, and it will change this whole page. Or you can just add more pages if you want. But in our case, we just want a basic application, so that's what we're gonna do. So back to the editor we are. Now that we have the React application, right, what we want to do is we want to create our Jenkins file, right? So what a Jenkins file is that it's just going to be the instructions that we're going to automate, so that whenever we do create our Jenkins pipeline, it's going to be the steps that our pipeline will run. So let's do that, right? Let's create the Jenkins file within this simple React folder, because we're going to take the simple React folder, we're going to put it into GitHub. And at least now we know that when we put this in GitHub, the instructions for what to do with that React application is already in that folder. So let's do new file, and let's call this Jenkins file all together. And if you have Visual Studio Code, you can already see a little butler on the side because it already knows what a Jenkins file is, right? So let's start creating the instructions for a Jenkins pipeline. Now, what we're going to do is we're going to create a pipeline. So what we're going to use is the word pipeline, and open up some curly braces. And the first thing we're going to specify is the agent. And we're going to say that it's going to be any agent. And what agent any means is that Jenkins will run the job on any of the available nodes that Jenkins have to offer. Now we can specify another agent if we have it available, or if we created one. But in our case, we're not going to create it, so we're going to say any agent that's available we'll use for our Jenkins pipeline. The second thing we're going to do is we're going to specify the tools that we're going to utilize within this pipeline. So one tool that I want to specify, and by using the tools keyword and opening up some curly braces, is I want to specify that we're going to be using Node.js in this process, because we're going to be running npm commands within this pipeline. So we got to make sure that the dependency of Node.js is within this pipeline. So the tool that I want to specify is Node.js, and I can do that by using the word Node.js and giving the string of node, right? Because when we create our Jenkins instance, we're going to download node on that Jenkins instance, and we're going to give it a name of node. So that's how it knows where to get that Node.js version from, right? It's gonna go in, it's gonna check, oh, is there anything that's associated to Node, and we're gonna already have Node.js downloaded in our Jenkins instance, and it's gonna plug that into this pipeline. And then now we can run npm commands, because now we have Node.js throughout the pipeline. And then now we can start specifying the steps that are going to be automated every single time we run this pipeline. So we can specify the stages, right? So use the keyword stages, open up some curly braces, and now for each stage is essentially going to be, like I said in the previous portion, or the CICD portion, is going to be the chunks of tasks that this pipeline is going to do. And then when that chunk is done, or when that task is done, it's going to move on to the next task. So we can define stages for each individual thing. We might have a stage for installing dependencies. You can have a stage for running tests. You can have a stage for deploying. So this is where we do it within this stages curly braces. And it makes sense, right? Stages is plural, so we can have multiple stages within this section, right? And to define a stage, we just got to use the keyword of stage, right? And that's singular, right? There's one stage, but there could be multiple stages within this curly braces. So let's do that. So open up some parentheses, and then open up some quotes and give a name to that specific stage. So in this case, I'm gonna give a stage name of install dependencies. And this is gonna do exactly that. So let me open up some curly braces, and I'm gonna define some steps, right, of what to do to install the dependencies. And really it's just one thing, right? We wanna specify a command using sh, and within quotes I want to specify the specific command that I want to run to install the dependencies. And you know, for npm, what you got to do to install dependencies is npm install. So if it sees a package JSON, right, because this pipeline is going to have access to this whole folder structure, right, this whole React folder structure, and once it sees this package.json and it runs the npm install command, it's going to download all the dependencies within this package.json, and it's going to create a node modules folder based on the dependencies that were installed. So that's exactly what I want to do within this pipeline, right? I want to first install the dependencies using this command of npm install based on the package.json within this folder structure, and then we can move on to the next stage, because now we have all the dependencies that we need to run a React application once it downloads properly. All right, cool. So that's just one stage, but now we want to run another stage, right? After that installs properly, then the next stage will be testing, right? We want to make sure that we have all the dependencies that we need, but we want to make sure that all the tests are running as expected. So I'm going to call this test and open up some curly braces and define the steps to run the test. And it's not really much or many steps needed to run the test. All we got to do is use a command, and we're going to use sh to run a command. And what we're going to do is npm test, because within this package.json we have scripts, right? And this script is test, right? To run the test for this React application, we just got to do npm test. And by default, this React application already comes with test already implemented. So if we go into the source folder and we do app.test.js, we can see that it already has a very basic test that runs and sees whether a specific text is within the app file, right? So it's going to see is if learn React is within the screen of this app file. So if we go into app, we can see that, let me see, learn React is right here. So we expect it to be there all the time. So that's what this test is checking for. And if that test runs properly, then it's going to move on to the next stage. So we can save that, right? So this is all we're going to need for right now. But in the future, or in the future of this video, we'll add more stages. But for now, this is a very basic Jenkins pipeline. We define the agent, right? We define the tools that we're going to need to run the pipeline. We define the stages, right? Stages is just multiple stages that we want to run throughout the pipeline process. So first, we want to install the dependencies based on the package.json, and then we want to run the npm test. Later in the video, we're going to actually add some stages to first build the Docker file, right, and then publish that Docker file or that Docker image. So that'll be later on in the video. But now what we have to do is we have to get all of this into a repository, right? Because what Jenkins is going to need a link to a repository to run our code. So I'll let you guys choose the one that you want to use. You can use GitHub, you can use Bitbucket, GitLab, but personally I like GitHub, so that's the one I'm going to use to store our code in our Jenkins file. So here I am in GitHub. I already started the process of creating a new repository. Like I said, you don't have to use GitHub, but when creating one on GitHub, what you have to do is specify the owner, give it a repository name, and hopefully it's available. In my case, I'm going to make a private repository until I make it public, but for now I make it private. I added a README so you can give a description on what's going on in the project, and even here this little description is optional, but I just said I'm creating a Jenkins pipeline. You can add a git ignore if you want to, which we could probably check if there's one for React. There isn't, but I'm pretty sure the template that created our React application already has a git ignore, so we don't really necessarily need it. So I'll put none for that. And then for the license, I usually just go for MIT license, but if you have one that you want to specifically use, then you can put that down here. And then just create the repository. And that was pretty quick, right? So now all we got to do is add that repository, or add this repository to our project. And what we're gonna do in the future is get this link from GitHub, and now Jenkins is gonna utilize this link to get access to our repository so that it can run the pipeline utilizing the Jenkins file that we just created as well. Alright, so now that we have our Git repository, alright, we have to find a way to link our local code to this Git repository. So what we could do is we can go into this little code button and we can get the link to our Git repository, right? This is SSH, so you do need a SSH key associated to your account, and I'm gonna leave a link in the description on how you can set that up for your Git account if you're using GitHub. It is a pretty quick process. You know, GitHub has a great documentation for it. I found that HTTPS just has a lot of issues, and honestly I don't even think GitHub allows you to use this anymore, so I don't really know why they provide it, but just do SSH so you don't have to deal with any headaches. Just do it from the beginning. You don't have to worry about anything if you have it set up. So cool. I'm going to copy this and move back over to our local repo. So back in the repo we are. What we got to do is, like I said, link this to our GitHub repository. And what we could do is first use the keyword or the command git init. Right, and what it's going to do is it's going to initialize a empty Git repository within our React folder, right? Make sure that you are in your React folder. Should I said that in the beginning, but make sure that it is in this folder of whatever you named your React folder. In this case, I'm in this simple React folder, and I did git init, and it's going to initialize an empty Git repository. And you can already see that, you know, this 19 popped up because, you know, Visual Studio Code comes with a source control extension. So if I go in here, I can see that all the changes that are associated to my folder, and in this case it's pretty much all of it because, you know, none of these were ever committed using Git, so everything is new. So now that Git is initialized in this folder structure, what I'm going to do is link this new empty Git repository to the GitHub repository I just created. And to do that, you can just do git remote add origin and paste in that URL that I just copied from Git repository or the GitHub repository, and then press enter. And to check that it actually went through properly, do git remote -v, and you can see that it has fetch and push access, so we're good to go. Now if I do git status, you can see that there are no commits yet, but we could start adding some of the files that weren't committed, which is pretty much everything. So one thing I want to talk about, and when I was doing the setup for the GitHub repository, I chose not to put a git ignore because I said that the git ignore already comes by default with the React app setup or the template. And as you can see, if I click this .git ignore, it essentially defines files that, or folders that we don't want to push into Git, right? And in this case, I'm defining, or it already came defined as node modules, because we don't want node modules in our, you know, Git repository. First, it can get pretty big, and second of all, we just want to allow everyone to just do npm install to get the proper dependencies based on the package.json right here, right? It already has the version. All they got to do is run npm install, and it will generate the node modules anyway. So we don't need to push that into our Git repository every single time, right? So this git ignore specifies that, and a whole bunch of other files as well, even some .envs, because sometimes people forget to put that, so that's good. So hope you guys understood that. Now let's do a git add, and I'm gonna do dots because there is a lot of files. If you want to do it one by one, that sounds dreadful, but this dot specifies that you want to do a git add of all. But just make sure that if you're gonna use this git add dot, that you have the proper files that you want to ignore in the git ignore, so that if you do this, then it's still gonna ignore those files, so you don't have to worry about adding those files that doesn't need to be added. So I'm gonna do git add. If I do git status again, you can see that these new files were just committed, and all we got to do now is do git commit -m original React push with Jenkins pipeline. Nice. Now we created a commit with a message, and now all we got to do is git push. Now one thing you could do is that you could create a new branch and give it another name, or you could push directly to main. I just left it as a default branch of master, but you could do whatever you want in this case, right? If you want to do a new branch, you could do git checkout -b, which let me show you guys. You do git checkout -b, and it can be a another branch, like give it whatever name that you want. It doesn't have to be feature either. It could just be whatever you want, like whatever name that you want. Branch name could go somewhere, like somewhere here, branch name, whatever you want to give. But in this case, I just kept that as a default master branch. So I'm just gonna copy this, and it's gonna just push this branch up to GitHub. Right. So if I switch over to GitHub, I should now see this master branch in our repository. So boom, you can see that less than a minute ago that master was pushed, and if I click on this drop down and view all the branches, go to master, we can see that our code is now there. Like now all of our React application is there. No modules folder because git ignore made sure not to add that, right? We ignored it. And we have our Jenkins file here. So now the whole point of it is that with this all in a repository, I can now use the same link that I got to create or to link the Git repositories. I can use this same link to put into Jenkins, and Jenkins can now extract all this information, see that there's a Jenkins file, and automate the process with this Jenkins file. So we're going to take baby steps, right? But we're getting there, right? We have this Git repository now. Now let's move on to creating a Docker file. All right, so now that we have everything in our Git repository, let's create a Docker file, right? A Docker file is just a set of instructions used for creating a Docker image. So a Docker image is just a template of instructions used to create a Docker container. So we'll use a Docker file to create a Docker image, and a Docker image to create a Docker container. And the container that we're trying to create is a Jenkins container, right? There is already a Jenkins image, but we need a Jenkins image with a little extra oomph, right? Because what we're gonna do is we want to run Docker within Docker, if that makes sense, right? I want to create a Docker container utilizing Jenkins, but within Jenkins, and within that pipeline, I want to push something to Docker. So to create that connection to Docker from within the Docker container, I'm going to have to download Docker from within that container. So I'm going to have to create a Docker file to adjust the instructions to do that. So let's create a Docker file, and I'm not going to put it in this React folder. I want to create it on the outside, and that's why the parent folder was so important, because I wanted the React application to have its own folder structure and then have any other outside files to be able to be in the parent folder in itself. So what I'm going to do is I'm going to do cd ... to go up to the parent folder, which is the Jenkins pipeline in my case. I'm going to do clear because there's a lot going on in this terminal. And now I'm going to create a new file called Docker file. And you can see a little boat, right? Because like I said, Visual Studio Code just understands it, right? It knows what it is, so you can see a little boat. And that's how you know you're doing something proper. Now, from within this Docker file, I want to put a list of instructions. And the first instruction I'm going to use is from. The from specifies the parent image in which we want to build off of. And in this case, I want to build from, and using from, I want to specify the parent image in which we are building. All right. So the first instruction I want to specify is from. The from instruction specifies the parent image in which we are going to build off of, and which in this case is going to be Jenkins. That's going to be our parent base image, because like I said, there's already a Jenkins image, but I want to add a little bit more oomph to it, but I'm still going to use it as a initial template. So let's do that really quick. So I'm going to do from Jenkins, and you can already see that it's already going to give you some examples of, you know, what we can get from. But I'm going to do Jenkins / Jenkins LTS, meaning the latest, right? And we should be good to go. This is going to be the base image, right? And this is going to be what we're going to be basing our instructions off of. Now we want to set the user to be the root, because we want it to have root access, meaning that we can do essentially what we want to do. So I'm going to set the user to be root. And the third thing I want to add is an update instruction, right? And what this is going to do is going to update the system internally to provide the most up-to-date packages and versions, right? So we're going to do run apt-get update. So we know now that we're going to have the most up-to-date versions and data packages. And with that, I can do the final run. And like I said, I want to use Docker from within our container, so I'm going to just install Docker. So I'm going to do run a curl command -s sl https get.docker.com/pipe sh. And what this is going to do is going to just run a curl command to get Docker, right? And it's going to be all downloaded within the container. And this is what we're basing our image to be. It's just a list of instructions. Give it root access, update the OS internally, and then run a curl command to actually get Docker, right? Because now we have access to running Docker from within the container. And this is going to be important when we have our pipeline, because I want to push and publish information in the future, because I'm going to push, or I'm going to publish a React application, right? And if I didn't have this, I wouldn't have access to Docker. So this is needed. So let me just save that. And now we have a Docker file, which is a set of instructions that we're going to use to create an image, and that image is going to create a container. And this container is essentially going to be a Jenkins container, but with an extra oomph to it. So now we can utilize Docker within the container. We can build our React application, and we can push it to Docker Hub using Docker commands. All right, so with all the instructions added to this Docker file, we can now create a Docker image based on this Docker file. And to do that, all we got to do is use the Docker build command. So let's do that. Docker build, and make sure it's not capitalized, but Docker build. And make sure you're in the same folder structure as where your Docker file is being held. So in this case, I'm in the Jenkins pipeline folder, and that's holding Docker file. So make sure you're in the same folder structure. And then you can do Docker build, and I'm going to give it a name using -t for a tag. And I'm going to use tech with geo /. And I'm just going to call this Jenkins app. So I'm giving it a name, and you know, the convention is usually your Docker username / the name of what you want to give the image. So that's what I'm doing here, and I'm going to put dot, and then press enter, and now it's going to be building the Docker image. And as you can see, it is building properly, and now you can see that it's Docker or tech with geo / Jenkins app, and we're good to go. And just to confirm it, I can see that it's here, tech with geo / Jenkins app. So we are good to go on that front. Now with the image that we created, all we got to do is run it. So let's do that now. So to run a Docker image, to create a Docker container, what we have to do is use the following command. Docker run. Actually, let me just clear this out first before I do that, because it's kind of getting a little bit convoluted here. So we can do Docker run -d, meaning detached, meaning it's going to run in the background. And we can do -p, and we're going to specify ports on where this Jenkins application is going to run locally. So we specify that with the first port, which is 8082 is where I'm going to run it. locally, and then we use a semicolon and specify the port that Jenkins is being exposed on. And internally, by default, I believe Jenkins is being exposed on 8080. So internally it's 8080, exposed on 8080, but then locally I want it to be routed to 8082. So host first, container second. And then what we're going to do is we're going to define some volumes. Now the first volume, and how we can do that is, -v. So the -v allows us to mount a volume, and what we're going to do is we're going to host the Docker daemon to the container so we can invoke the Docker API client from our container. So to do that, what we have to do is specify the path that we want to mount, and what we're going to do is going to be /var/run/docker.sock, and this is what Docker uses for that. And then we're going to mount it to the internal version of it, which is /var/run/docker.sock. Right? So we're good to go on that front. And then we're going to use another volume, and we're going to map the Jenkins running on the container to a Docker volume called Jenkins home. So what this is going to do is this is going to allow Docker to mount data from Jenkins so that even when we exit the container, when we re-enter the container, the data is still going to be available. So we just want to make sure that the data is maintained even when we close the container. So like I said, we're going to name this Jenkins home, and we're going to mount that to the following path from the container. And I forgot to put the -v. You got to put the -v in front of it each time you specify a specific volume. So there's going to be two -vs, right? There's going to be one for the Docker sock, and there's going to be one for the Jenkins home, right? And we're good to go on that front. Now on to the next thing, we're going to do --name, and this is going to give a name to the Docker container, and I want to name this Jenkins _container. And the last thing we want to specify is how are we building it, right? What image are we going to use, or what image are we trying to run? And in this case, it's going to be tech with geo /Jenkins _app, right? The one we just created based on the Docker file. And make sure that, in this case, whatever you named it as, you put here, but everything else should be about the same. Just make sure that you have, the ports open locally. So in this case, I'm using 8082 because right now 8080 is not available, as well as 8081. So I chose the next available port. And yeah, we should be good to go. Make sure you had that image built and use the name here, and we can press enter. And we can see that the hash code is created. Let's move over to Docker and see if it's running. All right, cool. So now we see that we have a Jenkins container, and it is running on port 8082. It's the latest version, and yeah, we're good to go. And I already had another version already running, and as you can see, it's running on 8081, so I couldn't use that one. But we have another one running on 8082, and it was running a couple seconds ago, so it's the same one. All right, so now let's begin the setup of Jenkins on localhost 8082. All right, so one important thing to note with this running Jenkins container is that if you click on this Jenkins container, you'll see that it's logging a very important password. And obviously, after this tutorial, I'll probably close this out, but and you probably shouldn't show this to anyone else, but there's an admin key that is generated, and what you will need to do is you're going to copy this, because when we go into our Jenkins website, right, we're going to have to place in this password to proceed with the installation. So make sure that you have this stored somewhere, because we're going to need this. Another way that you can get that information is you can use Docker logs and just put the container name. So in this case, it was Jenkins _container. And if you scroll up a little bit, you can see that it's right here. So that's just another way that you can get it if you don't feel like going through the GUI. Now, if you go to the port that you specified for your Jenkins container, you should now see this screen that says unlock Jenkins. And I show you guys how to get that code or that initial admin password using Docker logs, or you can click directly through the Docker GUI. But once you copy that, you can paste that here in this administrator password section or input, and then press continue. Alright, so you're going to have two options: either install the suggested plugins or select plugins to install. Now in this case, I do have a plugin that I want to install, so I'll click the second one right here. And you can get the dashboard view, so this first one right here, and then scroll down a little bit, and in the builds tool section, I want Node.js because we're going to need Node.js for our React application in the pipeline. And then go down a little bit more, and in the source code management, you can click GitHub or whatever source code management tool that you're using, whether it's GitLab or any other type, or Bitbucket. But in my case, I'm using GitHub, so I'll select that, and then we should be good to go. There's more plugins, so you can look through it and see if there's anything that meets your eye. But for what I'm doing, I don't need anything else. So press install, and then just give it a few, and I'll be back when this is finished installing. Alright, so once it is done, it will bring you to this create the first admin user page. And in this case, I'm going to use that because this is what you're going to use to log in into Jenkins as an admin. So you can create it here. So for the username, I'll just put admin. For the password, I'll just put a password. And make sure that it's confirmed. And after all of this input is filled out, we can press save and continue. And here is where the Jenkins URL is configured. Since we're running it on localhost and this is the port that it is running on, I'm going to leave it as a default. Press save and finish, and now we can start using Jenkins. So this is the initial dashboard for Jenkins. It even says welcome to Jenkins. So there's a lot of, or not a lot, but there's some configuration that we got to do before we should really get started or really dive in. So the first thing that I want to do is I want to go into manage Jenkins, and then I'm going to click on tools, and we just downloaded or installed the Node.js plugin. So if I go down from tools and I press add Node.js, remember when we were creating the Jenkins file, right, and we specified the tools that we'll need for the pipeline, and how I specified Node.js and the name for Node.js would be Node. Well, this is where we put the name, and this is why the name will be Node, because it can go in here now and see, okay, we have an instance of Node.js in our tool section, and the name is Node, so we'll use this version of Node.js. So we got to make sure that the names match. So in this case, I'm gonna make sure that it's called Node. And then we see the version here is 20.5.0. We'll leave it as that and leave everything else as it is, and just press save. So now if we specify the tools as the one that we just added here, then we'll have Node.js in our pipeline. So that's just one of the things that we have to do. Now if I go back to the manage Jenkins page and I click on plugins, we'll download a couple plugins that we'll need for our pipeline. So let's go into available plugins, and we're going to just type in Docker. So two things we'll need is Docker here, right, and Docker pipeline, right? Because what we're going to end up doing is we're going to end up using Docker to push our image to Docker Hub. So we're going to create a Docker image, and that's the reason why we install Docker into this Jenkins container. But we're going to use the Docker pipeline plugin to actually build and push the Docker image to Docker Hub. So let's do that. Let's install without restart, and it should successfully download as expected. And now if we go into install plugins and we search for it, it should be there, unless it's still installing, but that's fine. Well, it's not here, so I'm assuming that it installed properly. I'm gonna have some hope in that. So now the next step will be adding some credentials, right? So let's go back to manage Jenkins. Now in the manage Jenkins page again, this seems like a very important page. What we're gonna do is we're gonna go to credentials. And now in the credentials page, we're gonna go to domain and press global. Now on the global page, we're gonna press this add credentials. And now we're gonna specify some credentials. And this credentials is gonna be for our Docker profile, right? Because to push an image to Docker Hub, we're gonna need a Docker account. So if you don't have a Docker account, create a Docker account, and then with those credentials, you can put them here. So my username is tech with Geo, and then my password will be my password, and you can give it an ID. So it's essentially going to be an identifier, so that whenever, and we're going to do this, we're going to add the logic into our Jenkins file, and to grab the credentials, the ID is very essential. So whatever you use as the ID here will be what we use to retrieve it. So what I want to use here is Docker Hub creds, and that'll essentially be the Docker Hub credentials, and that's how, this is the name that I'm going to use to retrieve the credentials by. And then let me put the password here and press create, and then boom, now we have the Docker Hub credentials saved, and now we have access to it in our pipeline, right? All we got to do is specify the ID, and now we'll have the username and the password for our Docker account, right? And that's gonna be important for pushing the image to our Docker Hub account, so that we'll be able to run it on any machine if we need to. We just will have to pull from Docker Hub. Cool. So now that we have all of this set up, let's go back to the original dashboard, press new item, and what we're going to be building is a multi-branch pipeline. What this means that we can create a set of pipeline projects according to detected branches. So if we have multiple branches, we can create a pipeline for it. So it can be, like I said, a main branch, it can be a dev branch, it could be exactly that, and it will be able to listen for those changes, right? But for this tutorial, we're only going to be using one branch, but there's many configurations that you can put for it, right? You can have just a regular pipeline, you have a freestyle project, but in this case, I want to use a multi-branch pipeline, and I'm just going to call this a React pipeline. Perfect. And look at these options, right? And then multi-branch, and press OK. So here we are, right? We see a couple of inputs. So if you want to give it a display name, which I'm gonna do now, it's React pipeline. It's just what it's gonna be displayed as. We can give a description if we want to. This is a React pipeline. All right, so one mistake that I made with my repo, and that's just because I do it all the time, is that I made this repo private when I should have made it public. Now, you have two options with this. You can either make your Jenkins pipeline private and place your GitHub credentials into Jenkins, and it'll use your credentials to get the repository. But since I was going to make this public anyway, then I might as well just do it now, because this will be the reference point for whoever needs to get this information. So when making it public, I won't need to place my credentials as well. So it kills two things with one stone. So to do that, if you ever care to make anything from private to public, what you can do is go to settings, general, scroll all the way down to danger zone, because this is kind of dangerous. If you don't want to, you got to make sure that you actually want to make it from private to public, and some other stuff, right? If you want to disable some protection rules, etc., or transfer ownership, this is the danger zone. But in this case, I do actually want to change the visibility, so that is what I'm going to do. I'm going to change this to public, and I want to make this public. And I have read that I understand these effects. Make it public. Let me put the password real quick. All right, cool. So now our repo, or my repo, is public. So if I go back to master, so I'm gonna copy the HTTPS link, and I'm gonna bring that into Jenkins so that we can get Jenkins and this repo connected. So back in the configuration step, I'm going to add the source, do git, and then paste in the repository. No credentials is needed in this case. And if I scroll all the way down, anything else is we can leave as default. It's going to go and try to get this Jenkins file for it. It's going to scan for the Jenkins file and add the necessary steps for it. And then we can go ahead and save that. So I went ahead and scanned everything, and it was able to see that there were two branches found. One was main, and it didn't have a Jenkins file in it because we didn't put anything in the main folder. But then the second one I was able to see, which is master, and it did find a Jenkins file. So it went ahead and added that in here. So let's go back to status, and we can see that it's going to attempt to run initially the build. It's going to install the dependencies and all that, but because we don't have any npm, or actually we do have npm, so it should install the dependencies and it should run the test as expected. So let's see the console output while it does that. So you can see that the package .json was there, and it's going to do the npm install, and that's probably going to take a little bit, so we'll wait for that. All right, so it finished with a success. So let's just do a little recap really quick. I'll scroll all the way back up. This is the console output. So it's pretty much essentially all the logs that is occurring while it's running the steps. So initially it did search for the branches that are available. Master was the only one that had the Jenkins file, so that's what it's going to use. And then what it's going to do is going to fetch all the information from that Git repository, because we specified the repository. We made it public and specified the repository. And what it did was it went ahead and, after getting all the information from the repository, the first step was npm install to get the dependencies. And because we have Node on the pipeline, it was able to do that properly. It took some time, but it installed all the packages needed. And then the second step, right, was the npm test step, which, as you can see, it does npm run tests, and we saw that there really was only one test. So that test passed properly, and right now it goes all the way to the end. It was successful because it was able to run all those stages properly, and that's considered a success. So that was the initial Jenkins file. It was able to do everything as intended, but now it's time to make this a little bit more robust. What we want to do is we want to obviously do the npm install, obviously do the npm test, but we want to make sure that we're able to build this React application into a Docker image, and then push that into Docker Hub, so that we'll be able to pull from Docker Hub and run a React application on our machine without any issues. So that is what we're going to be working on. But at least now we know that we have a proper Jenkins pipeline running. We just got to add a little bit more steps to it. And a little cool thing as was, if you go back to the dashboard, you click React pipeline, you'll see that if it runs successfully, then you get this nice little green check mark and a little sunshine, right? So that's a little good thing for you. So cool. If you click on it as well, you can see it in like a little different format. But if you want to click on the logs and see it in the output that we just saw, you can do that as well. But it shows essentially what was done, right? So it did the checkout, got the information from the GitHub, installed the dependencies, and it ran the test, because these are the names that we specified for each stage. So you'll see it right here. So as we add more stages, you'll see the screen start to fill up a little bit more boxes with the stage names. Let's write the Docker file for our React application. All right, so now I am back in the code base, and now it's time to write our Docker file to create a Docker image for our React application. So what I want to do is I want to go into this simple React folder or directory, or whatever you named your React app as. Go inside of that directory and create a new Docker file. Now we have a fresh Docker file, so that when we build the image, you'll have access to all the information within this React application or this React folder. So the first thing we're going to need to run React is Node. So to do that, we can do from Node, and I said from Node latest, and that should be good. Now we have the latest version of Node, or we're getting the base image from Node. And then the second thing we're going to do is we're going to create a working directory for our application, and I'm going to call this /app. So pretty much whatever command that we run in this Docker file is going to be towards this working directory of /app. And then now I want to copy the package.json to this /app working directory. So essentially what it's saying is we're going to look for a package.json file in the same directory as this Docker file. So in this case, if we go down, we can see that there's a package.json, and this is going to have all the dependencies that we need for our React application. and I'm going to copy that into the working directory of /app. Then after doing that, I can do npm, or actually run npm install. And what this is going to do is, now that I have the package.json in the app directory, which is going to be in the container, and since I define this as the working directory, when I run npm install, it's going to see that there's a package.json in the app folder, and once I run npm install, it's going to install the proper dependencies within the container. Then after downloading all the dependencies, we can then copy the rest of the files into the app folder. So I can do copy dot, meaning everything within this folder or this simple React folder, and copy it into /app. And now that we have all the source folders, all the public folders, and the package lock.json is in there after running the npm install, all the files that we need regarding our React application is now within the container. What we need to do is expose a port for this React application, and usually the default port is 3000, so that's what I'm going to expose. I'm going to expose 3000. Now, to make sure that this application starts when we run the container, what we could do is use the CMD and define what needs to be executed when this container is starting up. So what I want to do is I want to run npm The weird thing about CMD is that everything is comma separated, so I have to do npm comma run comma start. So essentially what this is going to do is going to run the dev version of this React application, because now that we have the proper dependencies installed and we have all of the source folder and files inside of our container, we can now run the React application, and it's going to be exposed on port 3000. So that is really what we need on a simple case to run this React application in dev. Now you could run a production version. All you would have to do is build this React application using npm run build, and then have a separate server like Nginx to serve that build version, but I'll save that for another video. So let's just run a development version of the application. Let's push this image, or use this Docker file to create an image and push that to Docker Hub and run a development version of our React application. So cool. Now the Docker file is done, and now we just have to go into the Jenkins file and leverage this Docker file to create an image and push it to our Docker Hub. So let's go over to the Jenkins file. And the first thing I want to do in this Jenkins file is define some variables that we can use throughout the pipeline. So I'm going to create a section called environment, and just as the name implies, we're going to create some environment variables so that we can utilize it throughout the pipeline. So the first thing I'm going to create is the variable image name, and that's just going to be the image name of our application. So what I'm going to call this is tech with geo / react -app. And usually the convention is that you use your username, your Docker username, / whatever you want to name the image. So in my case, I want to name it react -app. So that's the first variable. The second variable is going to be the registry credential. So that's your username. Registry credential. And let's just call this tech with geo. And then lastly, it's going to be just a placeholder variable, and I'm going to call this Docker image. This is just going to be used to hold an instance of the Docker image. So I'm just going to have that hold an empty string for now. So cool. Now we have variables that we'll utilize throughout the Jenkins pipeline. But let's start creating the stages to build a Docker image and then push it. So let me scroll down a little bit, and we'll put it after testing. Let's create a stage called building image. Let's open up the curly braces, and we're gonna do steps, and then we're gonna do script, because we're gonna be utilizing a script, And remember, when we installed the plugins for Jenkins, there was a Docker plugin that we installed, a Docker pipeline plugin that we installed. And what this is going to allow us to do is going to allow us to utilize the script to build a Docker image. So how we can use that? Well, remember I said we just created this placeholder called Docker image. Well, we're going to utilize that by doing Docker image is equal to, and to utilize the script, all we got to do is docker.build and pass it the image name that we want to build. So what it's going to see is that, okay, we have a Docker file, because remember, this Jenkins pipeline has access to all of the files within Simple React, because in GitHub, that's what we stored, right? So when we push this Docker file to our GitHub, it's going to have access to this Docker file, and it's going to see, okay, we have a Docker file in this directory. We can build this Docker file, and we're going to build it based on this image name, right? We're going to call, once we finish building it, we're going to have an image with this name of techwithgeo/React app, or whatever name you choose to put in this variable. But all we got to do is pass the image name that we're going to call it, right? And this Docker build is going to create the image based on this image name. So pretty easy stuff. And that's the reason why I want to use it, because all you got to do is do docker.build. Now we do have Docker downloaded on this Jenkins container, right? Or this Jenkins instance. So we could have just ran an sh command and do docker build, but I just feel like this is more cleaner, and it's easier to read, right? It looks like it is plain English pretty much, right? Docker.build, and just provided an image name, and it's good to go, right? So the next stage we want to do is deploy the image, right? So I'm going to do stage, and I'm going to do deploy image as the name, open up some curly braces, define the steps. Then we're also going to utilize another script from the plugin that we installed. And now what we're going to do is we want to push it to the registry, right? So how we do that is we're going to do docker.withRegistry, and then we're going to give it a link to the registry, right? So the link to the registry is https://registry.hub.docker.com, and then we're going to need a comma, and we're going to need to provide our Docker credentials. Now remember, we created credentials in Jenkins, right? We created global credentials, right? And we gave it an ID, and remember I said that ID is going to be important. So whenever you create the Jenkins credentials earlier, we're going to utilize here. So before I called it Docker hub -creds. So now it's going to go in, Jenkins is going to go in, look at the credentials, look for the ID of Docker hub creds, and it's going to pass it in here, right? Because we don't want to pass in sensitive information like our password directly to the pipeline. That's bad convention, right? So we store the credentials, and then we just retrieve it by the ID, right? So that's how we do it. And then we're going to open up another curly braces, and then we're going to utilize this Docker image variable, right? Because now it's holding an instance of the image, right? So what we're going to do is do Docker image dot push, because we're going to push it to the Docker registry, and we want to give it essentially an ID, right? So in this case, what I'm going to do is to make it a unique ID, so that every single time we push, it's unique, it's new. I'm going to pass in the build number, because every single time we run a Docker or we run a Jenkins pipeline, it increments the build number. So it starts as 1, the next one will be 2, 3, 4, etc., etc. So I just want to make sure that every single time we push a new Docker image, it's considered a unique image because it is new. So I'm gonna push a Docker image with that build number, so we know when exactly that image was pushed, right? And it's unique each time. So to do that, what we're gonna do is open up some quotes, then we're gonna inject the build number, and to get the build number of the Jenkins pipeline, all we gotta do is do env.build, and you gotta use uppercase _ number, right? So this is going to get the build number of the pipeline, and it's going to inject it into this push. So now this Docker image is going to be pushed with that build number. Cool. So now we pretty much have all the changes that we need, and let me just go over, right? So this pipeline, what it's going to do is, first we created an agent defined as any nodes can pick this up. We define the tools. The tools is we want to inject node into our pipeline because we're going to need it to run some node commands. Then we get to the environment section, and I define a couple of variables that we will need, which is first going to be the image name, and I just use the usual convention of username slash the image name that we want to give, and in this case it's going to be React-app. Then there's the registry credential. In this case it's just going to be my username, which is TechWithGeo, but in your case it can be whatever you have as your username. And then there's the Docker image, which is just a placeholder in this case until we use it later on in the pipeline. Then we start off with the stages, right? And this is, each stage is going to be signified as a single task of what needs to be done. So the first stage is installing the dependencies. It's going to run an npm install. The second one is going to be npm test, because we want to make sure that everything is working as expected. And then the third one is going to be building the image, right? Because after running the test, if it's good, then we can go ahead and build it, right? So we're going to build a Docker image. We're going to pass that instance of the Docker image that was built to this Docker image variable. And then we go to the next stage of deploy image, right? So we're going to utilize that image placeholder that's now storing an instance of the image, and we're going to push it to the Docker registry or Docker Hub with our Docker Hub credentials. And that's going to also have the build number that's going to be constantly incremented for each build, and it's going to be pushed with our Docker image to make sure that each push is unique. So cool. That is the whole flow of our pipeline, and now all we got to do is push it to GitHub, and we can run this in our Jenkins container. So let's do, and then first let me save this, and let me just do a git status really quick. Whoops, got to be in the right folder. So let me cd into simple React. Then let me do git status to see what files changed. I see the only things that were modified were my Docker file and my Jenkins file. So I'm going to do a git add all, git commit -m, and just say Jenkins file addition and Docker file addition for React application. And then now git push, and now we should be good to go on that front. Now let's go back to Jenkins and run it. Alright, so we're back on the dashboard. So I'm just going to click on my pipeline. I'm going to click back on master, and let me just build. Press the build now. It should slowly, well not slowly, but it should start the build process. Let me click on that. Or actually, let me just wait here. I should see the updates of the new additions here, and I'll be back when that is done. Alright, so I am back, and it is done running. It did take a little while. It took 4 minutes to build the image and 3 minutes to deploy, but it was finished. And if I go into the output of it, right, console output, there's a lot going on, but you can see that from here it starts, or it checks that there is a Docker file. It does the Docker build with the tag of the name that I specified, the image name, and it just runs and goes through each layer, and it does what it needs to do, and then it logs in using the credentials that I set up, and then you can see that the login succeeded, and it has the tag of what I set up, and then it goes in, prepares it, pushes it, and it ended successfully. Now if I go over to my repository in Docker Hub, I already have it set up, and I already use like a little filter of React dash. And if you're not here, if you don't know how to get here, you can go to dockerhub.com or hub.docker.com, sign in, and then go to repositories, and if it went through successfully, you could see your image was pushed here. Or if you don't know exactly, or if you have too many already in your repository, you can use the search bar and search based on the name that you gave it. In my case, I gave it React-app, so I put React dash, and this popped up first. You can see that it was pushed a few seconds ago. So if I click on it, you can see that it's pushed, and you can see that the tag is actually 2 for this, because remember that this is not the first build, right? Remember how I gave it the build number Well, this is the second build technically, so that's why it's showing as a tag of 2, because this is the second build. Because the first build, if I go back, didn't even have that build image and deploy image stage, right? This was added on the second run, so just to clear up any confusion. But we can see that it went through as expected, and if we want to push a new tag, then it shows that you can do it here. Say for instance you want to do React app : latest, you can do that as well, but I like the number convention, but it's really up to you. So now that we have this, let's see if we can run it. So let me open up a terminal and let's actually utilize the image that we just created and push to our repository. Alright, so I have my Docker desktop open just so that we can see that it's running properly, so we can still see our Jenkins container is running as expected on port 8082. And let me just increase the size of this really quick. So now let's run our Docker image. So what I want to do is Docker run, and let me actually just make this a little bit bigger just in case, and move it a little bit to the side and move this up a little bit. Docker run, and then we're going to do it detached, meaning we want to run this in the background, and we want to define a port. Remember, we exposed in our Docker file, we made sure to expose it on 3000. Well, that means it's going to be exposed from within the container on 3000, but we have to still route that to our local machine. So to do that, we use -p, and we specify a port that we want to use on our local machine for the exposed item in the container. So I want to expose it still on 3000 on our machine, so that's what I'm going to do. And then I'm going to specify the port that it is listing on within the container, which is also 3000. So hopefully that helps. Just remember, the left side is local and the right side is the port that is being utilized within the container. So the container port on the right, local port on the left, right? And then now we can specify the name of the image that we're trying to utilize or trying to run. So it's going to be tech with geo, and then it's going to be React-app. And that is, and I believe that is all. Docker run, detach the ports that we want to run it on, and the actual image name. Let's run it. We get the little hash, and we should see it pop up here. Oh, that's what I forgot to give it. Let's delete that. 1 second. So let's bring that back up. Docker run, detach p. Let's give it a name, right? Just so it's not as, you saw the randomized name, it's not really helpful. So I'm just gonna call this React app, and I'm gonna use, I believe it's -remove, so that, or I believe it's -, I could be wrong, but I'm gonna just hope, right, and make sure my guess is right, that this -rm is so that when we stop the container, it just deletes the container. So let me run this. Oh, I guess it was -rm. All right, cool. And now we should be good to go. We see that React app is the container name, and we're seeing that it's running the tech with geo React-app latest, and it's running on port 3000. So let's go into our browser and see if it's actually running on port 3000. Boom. So as you can see, I am now on localhost 3000, and we have the React app as expected. It's running as expected, and that's awesome. So you can see the power of this, right? You can now, deploy or make changes to your GitHub, run the pipeline, and you can set up triggers to run your pipeline on deployments. And that's going to be the next step for the next video. We're going to actually have this running in the cloud on AWS, and we're going to set up triggers for it. But this is just a good introduction to it. We can see the power of the automation of it, right? We don't have to do any of that manually. So now we can just push to GitHub, run the pipeline. It's going to install the proper dependencies. It's going to run the test. It's going to build the Docker file that we have within the repository. It's going to create the image. It's going to push the image, and now we can utilize it locally, and we can even create a running instance on the cloud as well, because now we can create a container, right? We can utilize an instance of it. We can use AWS and Azure to spin up a running application using the image that we defined. So there's so many use cases you can do with it. You can even define more steps within your pipeline, like checking the code quality, checking if the tests are proper, if you're running enough tests, like the code lines are defined using tools like SonarQube. So there's a lot of things that you could do with this pipeline, but this hopefully was a nice, great introduction to Jenkins, Docker, and how to use all of that together. So if you found that useful, enjoyable, go ahead and leave a like, subscribe, and stay tuned, because like I said, we're going to take this onto the cloud. We're going to put this into AWS, and we're going to create a pipeline that runs on a trigger and hopefully deploy it. So stay tuned.